Welcome to a leader in affordable design solutions. The following is a brief summary of a recent project for a data center with cooling challenges using Computational Fluid Dynamics, CFD analysis. We start with a 3D model of the data center, which has been created for this project. 3 different sections of the data center have been included for analysis. First, the supply plenum, which is also called the raised floor plenum. Second is the main data center space, which contains all the racks and other electronic components. And third is the return plenum, through which the hot air goes back to the air handling units. This is the supply plenum, and there are a total of 5 air handling units. Air supply from the air handling units directly goes below the raised floor. In the zoom-in view, we can see supply and return faces of the air handling unit in the 3D model. Now we will come to the main data center space. Raised floor with perforated tiles connects the supply plenum with the main data center space. For this project, there were 3 types of racks. 400 racks with 11 kilowatts of load, 30 racks with 26 kilowatts of load, and last was 2 high-density racks with 50 kilowatts of load. We included structural columns in the 3D model as they were an obvious obstruction to airflow. We are now seeing the hot air return plenum. Hot air comes out from the main data center space through grills and goes back to the air handling unit. This is the complete 3D model of this data center. The CFD analysis has been performed on this model, and we will move on to the results. Temperature variation on the rack surfaces can be seen clearly. Maximum temperature is hovering near 100 degrees Fahrenheit for the 11 kilowatt load rack. Overall maximum temperature in this data center can reach up to 115 degrees, which is for the 26 kilowatt rack. Plot for temperature variations across the entire data center helps in identifying some hot regions. We will now look into the airflow pattern. Flow pattern in the supply plenum shows how air is getting distributed after coming out of the air handling unit. We will now examine airflow inside the main space. 6 kilowatt racks at the corner had high maximum temperatures despite taking insignificant amount of air. The contour plot here shows airspeed variation below the raised floor. We then could identify the racks which are getting the least amount of air and make recommendations. Please visit our website at dayansol.com and let us show you how your next data center or troubleshooting project can affordably benefit from Dayansol's CFD analysis. Thank you again, and we look forward to seeing you at dayansol.com.